Okay, class, so today our topic is going to be focusing on expressions and equations. Our objective of today is that students will learn how to write in scientific notation. So I will give you the definition of what scientific notation means. It is a short way to write big numbers into small numbers. A number is also written in two parts. So let me show you. So we have an integer, and that's going to be equal to 7.5336 times 10 to the third power. So this is scientific notation. This is where you'll have a number that's greater than or equal to 1, but is less than 10. And then you're going to multiply that by a power of 10. And how does scientific notation work? So I'm going to give you an example right here. So let me show you. So we have 300 is equal to 3 times 100, right? And we have 100 is equal to 10 squared. So we get 300 is equal to 3 times 10 squared. Both 300 and 3 times 10 squared have the same value. So you see how it can be written in standard form and in scientific notation, and they will equal the same thing. It's just shown differently. Now that you've learned how scientific notation works, I'm going to demonstrate how you can write a large number in scientific notation form. So we have an example right here. We have the number 840,000, and we're going to be writing it in scientific notation. So the first thing you're going to want to do is place the decimal after the first number, and you drop all your zeros. So let me demonstrate to you what I mean. So you have 840,000, right? You place your decimal after the first number, and you drop all your zeros. So you cross out all your zeros, and you're left with 8.4. Okay, so that's the first part of the scientific notation form. And so then we go on to the second part. And then you want to count the number of places you move the decimal and write it as a power of 10. So let me just demonstrate to you again what I mean. So you want to count the number of places you move the decimal. So 1, 2, 3, 4, 5. So then this becomes a power of 5. And your final answer is you get the first part, 8.4, and you multiply that by 10 to the power of 5. So this is the scientific notation, and I have given examples where you guys can try it. So here are 2 examples, and I want you to write it in scientific notation form. Okay, so for the U-try problems, I got 7.6 times 10 to the power of 6. And the second one, I got 3.57 times 10 to the power of 9. I hope that my answers match yours, and we can go on to the next section. Okay, so now that we have learned how to write a large number in scientific notation form, we're going to learn how to write a small number in scientific notation form. So the example that I have today here is 0.0000000075, which is a really small number. And the first step that we have to do, we're going to place the decimal after the first non-zero number, and we drop all the zeros. So I'm going to demonstrate to you what I mean. So we have 0.0000000075. So we drop all the zeros, and we place the decimal after the first non-zero number. So it's going to end up looking like 7.5. And so that's the first part of the scientific notation form. The next part is you're going to count the number of places you move the decimal and write the power with a negative exponent. And we do this because we're moving our decimal to the right. So let's demonstrate that. So since we have 0.00000000075, let's count how many times we move the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to look like 10 to the power of negative 9. So our final answer is going to be 7.5 times 10 to the negative 9. And that's how you write it in scientific notation form. So now I have a couple of you-try problems that you have to write in scientific notation form. So try these problems out. Okay, so for the first one, I got 9.2 times 10 to the negative 6. For the second one, I got 4.6 times 10 to the negative 8. So compare answers and make sure they match together. Okay, so now we have learned how to write large numbers in scientific notation form, as well as small numbers in scientific notation form. So now we have to know how to change scientific notation form back to standard form. So the first thing is, our example here, we have 2.96 times 10 to the 7th. So we want to change that back to standard form. Notice how if it's a positive exponent, it's going to be a big number. So you move the decimal to the right 7 places. So I'm going to demonstrate to you what I mean. So it's 2.96. So we're going to move this 1, 2, 3, 4, 5, 6, 7. And it's going to look like this. 2, 9, 6, 0, 0, 0, 0, 0. And so the final form of that is 29,600,000. That's going to be the standard form. So our next example is going to be a small number going back into standard form. So notice that if it is a negative exponent, it's going to be a really small number, which I just gave away to you. So you move the decimal to the left 5 places. So I'm going to demonstrate what I mean by that. So we have 8.34, and we're going to move the decimal to the left 5. 1, 2, 3, 4, 5. So now this is going to look like 0.0000834. And that's your final answer for the standard form. So I have a couple of you-tries. I want you guys to write these 2 questions in standard form. So for the first one, I got 7,420,000. And for the second one, I got 0.00091. So you can see how we have a really big number and a really small number. And I hope that my answers match with yours. And if not, rewatch this part of the video so you can learn how to write scientific notation back to standard form.